Imagine meeting a stranger on the street. Someone you have no shared history with, no emotional bond to, no particular reason to care about. Now imagine being asked to sacrifice something you genuinely want today, to hand that stranger a portion of your income. That is precisely what your brain is doing every time you attempt to save for the future. Neuroscience has confirmed it. Your future self registers in your brain in a manner that resembles how you process an unfamiliar face. Not as you. As someone else. And once you understand the specific neural mechanism behind that, every financial decision you have ever regretted will stop looking like a moral failure, and start looking exactly like what it is, a predictable feature of human brain architecture. This video is not about motivation. It is not about habit stacking, or visualizing your goals, or finding your why. Those frameworks are built on a flawed premise, the assumption that the primary obstacle to long-term financial decision-making is a lack of information or effort. The evidence does not support that. The obstacle is neurological. It has a name, hyperbolic discounting. It has measurable neural correlates. It has been studied in laboratories using neuroimaging equipment. And it has implications for why nearly every standard piece of financial advice, budgets, resolutions, goal-setting frameworks, tends to produce inconsistent results even in intelligent, motivated people. In this video, we examine the mechanism behind hyperbolic discounting, what the neuroimaging research actually shows, why conventional approaches fail structurally, and what the peer-reviewed evidence suggests you should do instead. Every claim in this video is anchored in published research. Where the evidence is preliminary, we will say so explicitly. Begin with the core phenomenon. When humans are offered a choice between a smaller reward available immediately and a larger reward available at some point in the future, we consistently and predictably choose the smaller, immediate option, even when, by straightforward arithmetic, the delayed reward is the superior choice. Psychologist George Ainsley documented this extensively. In his 1992 work on what he termed picoeconomics, Ainsley established that hyperbolic discounting is not an occasional quirk. It is a widespread, reproducible phenomenon observed across multiple domains, including financial behavior and, critically, substance dependency. This is not a coincidence. The same cognitive architecture that makes it difficult to forego spending today to invest for the future is structurally related to the same pattern underlying compulsive behavior generally. That is not a rhetorical flourish. That is the research. The term hyperbolic refers specifically to the shape of how humans value time. In a theoretically rational model, what economists call exponential discounting, a reward's value would decrease at a steady, consistent rate as it recedes into the future. Waiting one additional week would always feel equally costly, whether that week falls tomorrow or in a decade. Human beings do not behave this way. The value of a reward collapses sharply for very short delays, then levels off gradually for longer ones. The gap between right now and 1 week from now feels enormous. The gap between 10 years from now and 11 years from now feels practically negligible. This asymmetry explains a wide range of behaviors that appear irrational on paper, why people accumulate debt they fully intend to address later, why pension contributions feel abstract until retirement is imminent, why the next paycheck always seems like the right time to start saving. Today is categorically different from tomorrow, in a way that no subsequent day is different from the day after. For decades, hyperbolic discounting was described almost entirely in behavioral terms. Researchers could observe it, reproduce it in controlled experiments, and model it mathematically. But the underlying biology remained largely theoretical. That changed in 2004, when Samuel McClure and his colleagues used neuroimaging to observe what actually happens inside the brain when people choose between immediate and delayed rewards. Their findings were significant. Immediate rewards, options available now, produce stronger activation in the brain's reward circuitry, particularly a subcortical structure called the ventral striatum. This is the same region centrally involved in dopamine-driven motivation, in the anticipation of pleasure, and in responses to addictive substances. Delayed rewards, by contrast, engaged regions more associated with planning and higher-order evaluation. The practical implication: when you are deciding whether to spend or save, you are not running a single, unified calculation. You are running two competing systems, and the one most likely to produce an immediate emotional response has a neurological head start. Cable and Glimcher's neuroimaging research further identified how networks involving the ventral striatum and prefrontal cortex are implicated in the evaluation of choices involving trade-offs under uncertainty, adding anatomical resolution to what behavioral work had long suggested. The prefrontal regions involved are capable of longer horizon reasoning. But they do not always win the competition. When the ventral striatum signals strongly enough, the more deliberative systems can be overridden. The critical insight here is that this is not a bug introduced by poor financial education. It is the operation of a system that evolved long before financial planning existed as a concept, a system designed to prioritize tangible, immediate resources in an environment where the future was genuinely and frequently lethal. Here is where the conventional financial advice collapses entirely, and where understanding the neuroscience becomes genuinely actionable. If this were an information problem, telling people the math would solve it. Nobody lacks the ability to calculate compound interest. The obstacle is not knowledge. It is that the architecture of the problem has been misdiagnosed. And misdiagnosing the problem guarantees the wrong prescription. The dominant framework in personal finance, education, goal setting, budgeting, motivational accountability, operates on a consistent underlying assumption that the problem is primarily motivational or informational. If people understood the math, or simply tried harder, the behavior would improve. The neuroscience suggests this framing is incorrect at a foundational level. Consider the role of emotional state. Research by Luhmann in 2013 indicated that stress and anxiety directly influence discounting behavior. Individuals under emotional strain demonstrate a stronger preference for immediate rewards. This is not a trivial finding. It means the circumstances under which financial discipline is most required, economic uncertainty, financial pressure, life stress, are the exact circumstances in which hyperbolic discounting is most pronounced. Asking someone under financial stress to override their immediate reward circuitry through willpower is asking the most of a system at the moment when it has the least capacity to deliver. The advice is internally contradictory. There is also the question of individual neurological variation. Research by Shields and Hawk in 2010 found that individuals with ADHD exhibit significantly elevated levels of hyperbolic discounting. This matters not because the majority of any given audience has ADHD, but because it illustrates that discounting behavior exists on a spectrum, and that the behavioral gap between different people is not fully explained by effort or knowledge. Some individuals, by the structure of their reward circuitry, are more susceptible to this effect than others. A willpower-based framework fails them not occasionally but categorically. And then there is this. Research by Green and colleagues in 1996 found that the magnitude of hyperbolic discounting tends to decrease with age. Older adults generally display more patient decision-making than younger ones. If self-discipline were the primary variable, one might expect experience and motivation to matter more than biology. The age correlation points elsewhere. It suggests that a significant component of this behavior is tied to neurological maturation and architecture rather than character. Telling younger adults, who face the longest investment horizons and the highest potential benefit from delayed gratification, to simply exercise more discipline is biologically asking the most of those with the least natural neurological advantage. If willpower is the wrong lever, the question becomes, what is the right one? Across multiple lines of research, the answer points in a consistent direction. Structural intervention, designing the decision environment so the problematic trade-off never arises, outperforms motivation-based approaches in the evidence base. The most robust category of evidence involves what researchers call commitment devices. A commitment device is a mechanism that constrains future choices in advance, one in which you remove a specific option before the moment of temptation arrives. The simplest form is automation, savings or investment transfers that execute without requiring a recurring decision. Xavier Jain and colleagues in 2010 studied commitment savings contracts, financial products specifically structured to limit access to deposited funds, and found that they improved long-term financial outcomes for participants. The mechanism is architecturally elegant. If the decision to save is made once, in advance, and the funds become structurally unavailable for immediate use, the hyperbolic discounting mechanism is bypassed rather than defeated. The ventral striatum does not register a trade-off because there is no apparent trade-off to register. This is the underlying logic of automatic enrollment in pension and retirement schemes. When saving is the default, and opting out requires active effort, a significant portion of the population that would otherwise never save consistently does so. The behavior change does not come from improved motivation. It comes from the decision being moved to a context where the prefrontal system, which can evaluate long-horizon outcomes, makes it once, rather than the reward circuitry re-evaluating it every month against competing immediate demands. Evidence in this area also suggests, with medium confidence, that interventions targeting the prefrontal control system, including structured mindfulness practice and cognitive behavioral approaches, may reduce discounting rates over time by strengthening the mechanisms that regulate impulsive responses. This is a longer horizon intervention and the evidence base is less uniform than for commitment devices. But it is directionally consistent with the neuroimaging findings. If the competition is between the reward circuitry and prefrontal regulation, anything that systematically develops the latter is working with the architecture rather than against it. The practical framework synthesizes to three components. First, remove discretion. Any financial behavior you want to execute consistently should be automated to the greatest extent possible. The goal is to make the desired outcome the default outcome, one that requires active effort to undo rather than active effort to maintain. Second, reduce the psychological distance of future consequences. Research in this area suggests that vividly and specifically imagining your future self in a concrete situation, not as an abstraction, but as a real person facing real circumstances, can reduce the perceived temporal gap and make future outcomes feel more like present concerns. Third, externalize accountability. The commitment savings research suggests that external structural constraints are more reliable than internal resolve. Peer contracts, automatic rules, and structural limits reduce the number of decision points at which the immediate reward system can intervene. Hyperbolic discounting is not a character flaw. It is not the result of insufficient willpower, poor financial education, or a failure of values. It is a feature of how the human brain evolved, shaped by an evolutionary environment in which immediate, tangible resources had genuine survival value, and in which the future was uncertain enough that heavy discounting of it was often the rational response. The ventral striatum did not develop for a world of compound interest, defined contribution plans, and 30-year investment horizons. It developed for a world in which today's food was more valuable than next month's. Understanding the mechanism changes the prescription. The question is not, how do I become more disciplined? The question is, how do I design my financial environment so that the architecture of my brain is no longer working against my interests? The research of Ainsley, McClure, Gine, Green, and others does not offer a motivational answer to that question. It offers a structural one. Automate the decisions you cannot reliably make in the moment of competing desire. Use commitment devices that bypass the trade-off rather than requiring willpower to win it each time. Reduce the frequency with which the immediate reward system is asked to stand down. The neuroscience does not make long-term financial planning easy. But it makes it legible. And a problem you can map accurately is a problem you can engineer around.